Hello, Dashiell. I hope you are doing well. Good to see you again here in this what is it, virtual classroom. And right now, where are you now, Dashiell? In Manila or?
In the Philippines, sir, in like the Visayas region, Region 6.
Hmm, okay. And I only know Manila about Philippines, only the capital city. So you live in Manila or in different province?
I'm in a different place, sir. Manila
Hmm,
is very far from where
I
I am
I
right now.
see. I see. Yeah, I have been working with Filipino teachers for a lot of years, almost like 16, 17 years. Even right now, we have a few teachers from Philippines that teach English and um, some different subjects here. Okay, so let's continue. Good to see you again. So our topic, as you know, is about indices and logarithms. In our first week, last Sunday, we talked about indices, how to write, what is it, uh, a product of the same number, right, in a compact form. So actually, after that, actually logarithm counts because in some situations we cannot solve indices without the help of logarithms. That means that force mathematicians to introduce new concept logarithms. For example, 2 to the power of x equals 3. How do you solve this? We don't have any algebraic way to solve this. The only way is we have to introduce new concept. Anyway, so what is logarithm? Simply, logarithm is an inverse function of exponents. What do we mean by inverse function? That means that if you raise a, for example, to the power of x, that means that we obtain a power function, right? Again, if we just take the logarithm of that function with base 2, then we get the original function back. So simply how actually logarithm was born, maybe it has a long history. Simply, for example, one situation is 2 to the power of x is equal to 3, for example, right? Okay, we may approximate this answer, right? We can guess its answer, but the question is, how do you write this x, right? How do you write this x alone? So if you don't have any idea about logarithm, there's no any way to describe this x equals something, right? So the only way is we have to introduce new thing. So that's actually we call this logarithm. So what is logarithm? Logarithm is that here x, the solution of this equation, is expressed as logarithm of 3 to the base 10. How should we understand this? We should understand this as 2 to the power of x is equal to 3. And after that, of course, uh, based on this definition, we can have some properties and blah, 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 blah. So if a number y is expressed as the exponent x of another number, like y is equal to a to the power of x, right? Of course, here a must be greater than 0 and a is not equal to 1. And why is it so? If a is not positive, if let's say it's negative, negative to the power of x, okay, its behavior will be so weird. And also in practical situations, in applications, we don't have this kind of phenomenon. Okay, so a must be positive. And also a should be different from 1. Why? Because 1 to the power of anything is equal to 1. There's nothing to learn here. That's why we need to add this let's say conditions when you're defining this. So we say that x is the logarithm of y to the base a. So we write it as, what is it? X equals logarithm of y to the base a, which means that it is equivalent to a to the power of x is equal to 1. Because in solving a lot of logarithmic equations or problems, we will actually change this into exponential form. And after that, we can deal with that problem. So in general, so here we have if y equals a to the power of x, then x is equal to logarithm of y to the base of a. Or if x is equal to logarithm of y to the base a, then it is the same thing as y equals a to the power of x. So interchangeably, we are going to use these two different notations depending on the context. And this is how logarithm was born because of this situation. And sometimes in many books, actually, if the base is 10, simply we just denote this by log 10. Log 10 means the base is 10. So logarithm of something to the base 10, or just log of x, that's logarithm of x to the base 10, which is called common logarithm. In some books, even we just write LGX, they are all the same things. Well, actual base is 10. And also we have another special logarithm, but we will learn about this later. That is natural logarithm, right? When the base is E, the constant E. Okay, so we have some properties of logarithms. Number one is if m and n are positive numbers, k an integer, and a is positive, a is not equal to 1, then logarithm of mn to the base a is equal to logarithm of m to the base a plus logarithm of n to the base a. Number two is logarithm of m over n to the base a equals log m to the base a minus log n to the base a. And also the things, and of course, in learning math, you know, the best way is we need to we should understand, especially the proving stuff, especially for the students who are studying for or preparing for math Olympiad, right? We should actually make a habit of asking WH questions. Why is this so? Why actually all of these properties are true? And how can we prove this? Proof is not so hard. Okay, maybe I'll show you only one, because if you prove all of them, we don't have that much time. And using this idea, also you can study, we can try to prove other stuff. For example, the first one, let's prove the first one. Why logarithm of m times n to the base a is equal to this? Simply suppose that logarithm of mn to the base a, let's say, is equal to some function. Let's say is equal to y, because if you calculate, we get something, right? And using the definition, we can just write it as m times n is equal to a to the power of y. Okay, so now from here, okay, so a to the power of y is equal to m times n. All right, so now if I just take, all right, a, so we have to write this logarithm of m plus logarithm of n. So I think I better write this like this. Okay, I can just write in a different way from right hand side to left hand side, because the property, either using right hand side we have to obtain left hand side, or using left hand side we need to obtain right hand side, right? Anyway, I'm just going to use this one. Let's say logarithm of m to the base a, let's say, is equal to x. Okay, and logarithm of n to the base a, let's say, is equal to y. Now using the definition, then what is m? M is equal to a to the power of x. And from the second one, what is n? N is equal to a to the power of y. So now if you multiply side by side, here we have m times n is equal to a to the power of x times a to the power of y. And using the property that we have studied in the last week, I can just write the right-hand side as a to the power of x plus y, because the bases are the same. We can just add the exponents. So now if I just take the logarithms of both sides to the base a, what happens here? Logarithm of m times n to the base a. On the right-hand side, we have logarithm of a to the base a, and here we have m plus n. Okay, so on the left-hand side, we have this. On the right-hand side, logarithm of a and to the power of m plus m. Actually, it just comes to the front. That's just equal to, no, it's x plus y, right? Why did I write m plus m? It's x plus y. So this one is x plus y. So this x plus y comes to the front. So here we have just x plus y. And what is x? X is equal to logarithm of m to the base a. And how about y? Y is equal to logarithm of n to the base a. In a similar way, if you just divide, we will get the second property. And third property comes from the first one, because m to the power of k means that I can just write it as logarithm of, here we have the base a, m to the power of k means we can write it as m times m times m dot dot, here we have m. How many m's? Here we have k m's. Here we have k m's. And if I just apply the first property again and again, k times what we have here. So that's equal to logarithm of m to the base a plus logarithm of m to the base a dot dot, and logarithm of m to the base a. And how many terms do we have here? N, because here we have n, k m's. So that's just equal to k times logarithm of m to the base. And how about number 4? From number 4 is, see here, a to the power of 0, that's equal to 1. Or number 5 is a to the power of 1, always is equal to a. Okay. Dashil, are you on holiday now? Is it summer holiday in the Philippines?
Yes, sir.
So when does your school open? August or September?
September, sir.
September. So 1 more month. How old are you, Dashil? 14 or 15?
14. I am 14, sir.
14. Good. Okay. Example 1. If p is equal to 1 over 4, without using a calculator, find the value of p times logarithm of p to the base 2. So here, solution, p is equal to 1 over 4. So here you need to calculate this, p times logarithm of p to the base 2. Okay. So now from here, what can we write here? P is equal to 1 over 4, just substitute here. P is equal to 1 over 4 times, here we have logarithm of 1 over 4. So this 1 over 4, right, we can just write it as 2 to the power of negative 2. So here we have 2 to the power of negative 2 to the base 2. So now using the property, this is just the power, it comes to the front. So here we have 1 over 4 times negative 2 times logarithm of 2 to the base of 2. So which is equal to 1 over 4 times negative 2, that's equal to negative 1 over 2. Logarithm of 2 to the base 2, that's equal to 1. So the answer is, if you just calculate this, it will be negative 1 over 2. Question example 2. Find the value of this. And I think this might be easier for you. As you see here, all the bases are the same, 3, 3, 3, 3. What we have to do is we're just going to use the property number 1 and number 2, right? So if the bases are the same, if they are added, we should just multiply the logarithmic, I mean, these numbers. So here we can just write this logarithm. The base is 3. So first, if 14. It is subtracted, that's why I should divide by 12 over 12 multiplied. So here we have 486. As simple, you can just write it like this. If you just group them, so these two, right, because they are added, we should actually multiply. And these two things, they are subtracted, right? So first, if you add and subtract, after that, we can combine them. So at the time, it will be just one fraction. What we have here, we have 14 times 486 over, here we have 12 because divided, and here we have 7, which is equal to logarithm of, in the base we have 2. Here the 7 and 14, here we have 2, and 486 is divided by 12. What is it? 286 is divided by 12, that's equal to 81 over 2. So with 2, that's equal to just 81. So that thing is equal to 81. So here we have logarithm. What is 81? 3 to the power of 4. And here we have 3. So the answer is 4. All right. How about solving logarithmic equations? To solve the logarithmic equations again, just we need to change them into exponential form. And after that, using the properties of exponential equations or exponents, we can solve the equation. So starting from here, we have 3 logarithms, right? So logarithm of something to the base 7 is equal to 0. So that means that actual logarithm of, here we have 5, and here we have logarithm of x to the base 3. It should be equal to 7 to the power 0, which is 1. Or again, one more time, logarithm of x to the base 3 is equal to, here we have 5, right? It is 5 to the power of 1. Now from here, then what is x? X is equal to 3 to the power of 5, which is equal to 3 to the power of 5 is 81. 3 times 81 is 243. So that is the solution of this equation. Solve the equation for x. Here, log, we cannot see the base. That means that the base is 10. Right? So let me just take 1 to the right-hand side and combine these two logarithms since they have the same base. So here we have logarithm of it is plus, so that here we have x plus 3 times x plus 12. On the right-hand side, we have 1. So which means that here we have x, if you just expand this, x squared, 3x, 12x, so here we have 15x, that's 3 times 12, that's equal to 36. So here we have 36. On the right-hand side, the base is 10, 10 to the power of 1, here we have 10. Or x squared plus 15x plus 26, that's equal to 0. So now if you just solve this by factorization, it is 13 times 2, and this one is 13 plus 10. So we can just factorize it as x plus 2 and x plus 15, that's equal to 0. From here, x equals -2, or x should be -15. And of course, in the definition, we say that actual logarithm of x, right, or something to the base a equals something. So that x, right here, we have logarithm of, let's say, whatever it is, here a to the base b is equal to x. What is the condition? This a, right, should be greater than 0. It cannot be negative, right?
Sir,
So
did
that
you
means
mean
that
13 or 15?
huh?
For
13,
like,
13.
yeah.
Thank you. It's 13. 13. So if it's -2 plus 3, it is positive. -2 plus 12, it is positive. If it is -13, this x plus 12 will be negative, right? And that's why this answer is rejected, because it does not fit the definition, right? So the answer is only 2, -2. So dots, dots, dot, the solution of this equation is only -2. Okay, another equation, logarithm of x to the base 10 to the power of 4 minus 3 times logarithm of x to the power of base 10 squared minus 4. And it says here x is greater than 1. So if x is greater than 1, then logarithm of x to the base 10, it should be greater than 0, right? Why? Because logarithm of, if x equals 1, logarithm of 1 to the base 10, it will be 0. So, Dashel, what do you think? How would you solve this equation? Just tell me your idea. If you have to solve this question, what would you do in the first step or as a first step?
Simplify it, sir.
How would you simplify it? I will do like this. Let me just introduce new variable. We call this auxiliary variable in math. Let's say this w is equal to logarithm of x to the base 10. And of course here, since x is greater than 1, right? So also this logarithm of x to the base 10, it must be greater than 0. Why? Because if in logarithm, if x is between 0 and 1, this logarithm of x to the base 10 at the time it will be negative. Otherwise, it is positive. So from here, if I substitute here, then w to the power of 4 minus 3 times, here we have w squared minus 4 will be equal to 0. So now, if you just solve this by factorization, -4 times 1, -4 plus 1. So here we have w squared minus 4 plus 1, right? That's minus 4. And here we have the w squared plus 1 is equal to 0. So if you just expand this w to the power of 4 minus 4w squared plus 1w squared, the sum is -3w squared, and that's equal to 1. Everything's okay. Now from here, w squared should be equal to 4, or w squared should be equal to -1. And since we are talking about the real number system, we don't have any real number whose product, whose square is negative number. So this is rejected. And also this has two solutions, right? So w is equal to 2, or w is equal to -2. And also at the beginning, we say that actually it is greater than 0. Why? Because of this condition, x is greater than 1. So also, this is not a possible answer for us. That's also rejected. Now we have only one answer. Then what is w? W is logarithm of x to the base 10 is equal to 2. So from here, dot, dot, dot. What is x? 10 squared. So the solution is 100. It has only one solution. If w is equal to -2, what happens there? X will be less than 1. It will not be greater than 1. Change of base formula. Have you ever seen this formula before, Darshan?
Not yet, sir.
Sometimes, especially in solving questions, or in some exams, for example, the table of logarithm is given to base 10. And using those table, actually need to solve the question, especially if you're not allowed to use a calculator, or even in solving a lot of equations, we may have to change the base of the logarithm. At the time, if you're given a logarithm of b to the base a, for example, I can just change this to any other base, like for example, c, logarithm of b to the base c over logarithm of b to the base c, or that's equal to 1 over logarithm of a to the base b. So in general, logarithm of b to the base a is equal to 1 over logarithm of a to the base b, or logarithm of b to the base c over logarithm of b to the base c. And why is it so? Proof is also simple. Suppose that, let me just label this logarithm by x. So x is equal to logarithm of b to the base a. So by definition, what is it? By definition, it's equivalent to this expression, right? A to the power of x is equal to b. So now let's just take the logarithm of both sides to different bases. For example, to be logarithm of something to base c, for example. So here we have logarithm of a to the power of x to the base c is equal to logarithm of b to the base c, right? And we can just do this because in equation in math, right, if you just carry out the same operation to both sides, it does not change the solution. Simply, it produces equivalent solution. Now, using the property of logarithm, this is just a power, right? It just comes to the front. So here we have x times logarithm of a to the base c. On the right-hand side, we have logarithm of b to the base c. So now, if I just take it to the right-hand side, what happens here? Here we have x equals logarithm of b to the base c over logarithm of a to the base c. So what is our x? Our x is, it's just this, right? That's equal to logarithm of b to the base a. On the right-hand side, we have logarithm of b to the base c and logarithm of a to the base c. Now, just a condition, if you just consider this condition, how about if b is equal to c? This special condition. At the time, logarithm of b to the base b, it will be just 1. In the denominator, we have logarithm of a to the base b, because b is equal to c. This is how we change the base of logarithm. Okay, now let's see one example related to this. Example 6. Let x be positive and also y be positive real numbers. And if logarithm of x to the base 3 times logarithm of 2x to the base x equal times logarithm of y to the base 2x is equal to logarithm of x squared to the base x, then we should find the value of y. And since actually x is in the base, right, and also in the value of the logarithm there, so we have one condition here that, okay, x is greater than 0, and also x should be, what is it, different from 1, because of here, it appears in the base. That's for also x should be different from 1. So under this condition then, what can I do here? So either I have to change the bases, or, so the first one, right, I can just write it as, let me just form here. If I just write upside down, I can write it as 1 over logarithm of 3 to the base x. The second one, here we have 2 multiplied, right? I can just write it as logarithm of 2 to the base x plus logarithm of x to the base x. Multiply, so I'm just separating this. And the last one is just 2x. What can I write here? I need to have the same basis, so also I can just write it as y over, 1 over logarithm of actually this 2x to the base y, and also this 2x, we can just simplify this, right? That is logarithm of 2 to the base y plus logarithm of x to the base y. So on the right hand side, actually just power, right, comes to the front. Logarithm of x to the base x, that's just equal to 1. So that's equal to 2. So now if we simplify what we have here, again, first one, let me just write in the fraction, logarithm of 2 to the base x. So here we have logarithm of 2 to the base x. Logarithm of x to the base x, that's equal to 1 over, and logarithm of 3 to the base x times, how about here we have 1 over logarithm of 2 to the base y. Okay. All right, how about if I just take this to the right hand sides? So if I just take this to the right hand side, we have 2 times logarithm of, let me just keep it as 2x, okay, 2x to the base y. Even I don't have to put this parenthesis here, times. Okay. Oh, I got a different idea here. Shall we need to, we can do something else. Okay, now I see this. We have a shorter way of solving this question. So this part, actually, these 2 expressions, I can just write it as logarithm of 2x to the base x. And the first one, we can just write it as logarithm of x to the base 3, right? So if we just bring this to the denominator, it will be logarithm of 3 to the base x times, here we have logarithm of y to the base 2x. On the right hand side, here we have just only 2. So now if you look at these bases, the same, right? I can just write it as logarithm of, it's like c, logarithm of b to the base c, logarithm of a to the base c. So I can just write it as logarithm of 2x to the base, what is it, 3. And here we have times logarithm of y to the base 2x. On the right hand side, we have 10. Again, actually, I can just write this thing, right, as, okay, first, let me just write the logarithm of y to the base 2x over this one, just change upside down by using the previous property. I can just write it as logarithm of 3 to the base 2x, because logarithm of a to the base b equals 1 over logarithm of b to the base a. So that's equal to 2. So now I see here the bases the same. So now from here, I can just write it as logarithm of y to the base 3 is equal to 2. Dot, 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 then what is y? Y is equal to base 3, 3 squared, that's equal to 9. So the value of y in this equation is, it is 9. Is it clear, Dasha?
Yes, sir.
All right. So we have a few questions in exercise 2. Okay, now after getting some basic ideas, we can solve them a bit faster. So find the values of the following expressions without using a calculator. So the first one is, as you see, the bases are 3 and it's added. So I can just write it as logarithm. In the base you have 2, 3, 5 over 7, 5 over 7 times 7 over 5. So that's equal to logarithm of is equal to 1 to the base 3, which is equal to 0, because 3 to the power of 0 is equal to 1. In a similar way, how about the second equation? The second equation is logarithm of base 3. 63 is divided by 7. 63 is divided by 7, which is equal to logarithm of 63 is divided by 7 is 9 to the base 3. So 3 to the power of what number is 9? It is 2, because 3 squared is equal to 9. And how about C? Let me just see here. 6 times logarithm of 2 to the base 8. So I can just write it as what? For example, I can just write it as 6 times logarithm of 2 to the power of 1, and this 8 is 2 cubed. So again, using the last property, here we have m, and this one is m. They just come to the front. 1 will be in the numerator, 3 will be in the denominator. So that's equal to 6 times 1 over 3 times logarithm of 2 to the base 2. So which is equal to logarithm of 2 to the base 2 is equal to 1. 6 times 1 over 3, that's equal to 2. So the value of the expression C is equal to 2. And how about D? D is equal to 2 times logarithm of 1 over 2 to the base 12, right? I can just bring this inside. It will be the power of 1 over 2. So I can just write it as logarithm of the base. Here we have 12. Here we have 1 over 2 squared, plus logarithm of 1 over 3. The base, we have 12. So now bases are the same and they are added. So that's just the same as logarithm in the base 12. So here we have 1 over 4 times 1 over 3. So 1 over 4 times 1 over 3, that's equal to 1 over 12. So the value of this thing is equal to 1, because 12 to the power of 1 is equal to 1 over 12. No. Sorry. 12 to the power of what number is 1 over 12? That is negative 1. Because 12 to the power of negative 1 is equal to 1 over 12. Next question, find the values of the following expressions without using a calculator. Let's use green. The first one, it is 12, right? So I can just write it as logarithm in the base 12. 2 times square root of 3, that's equal to square root of 12. So which is equal to logarithm of, what is square root of 12? That is 12 to the power of 1 over 2. In the base here we have 12, which is equal to 1 over 2, because 1 over 2 comes to the front, and logarithm of 12 to the base 12 is 1. And how about B, logarithm of square root of 575 times logarithm of 5 again. So I can just write it as logarithm of, here we have, what is it, 575. I can just write it as 575 to the power of 1 over 2. The base we have 5 minus 1 over 2 logarithm 23 over 25. The base here we have 5. Now 1 over 2 comes to the front, and also actually 1 over 2 is a common factor. I can just factor out 1 over 2. Inside the parentheses or brackets, here we have logarithm of 5, logarithm of 5. So can just write a single logarithm of 5, and it is subtracted. So here we have 575. And let me just write here, equals 1 over 2 is a common factor. Here we have logarithm in the base 5. Here we have 575 is divided by 23 over 25. Okay. So that's equal to then 1 over 2 times logarithm of 5. What is 575? 575, if you divide by 23, that's equal to 25 actually. So that's equal to, here we have 25 times 25. So that's equal to 25 squared. So which is equal to 1 over 2 times logarithm of, in the base we have 5. 25 is 5 squared. So here we have 5 to the power of 4. So this 4 comes to the front. So that's equal to 4 over 2. That's equal to just 2. So the value of the thing is equal to 2. How about C? In C, the bases are the same, right? You can just write it as logarithm of 243 to the base 27. What is 243? It is 3 to the power of 5. And how about 27? It is 3 cubed. So which is equal to 5 over 3. Logarithm of 3 to the base 3 is just equal to 1. So it is 5 over 3. And how about the last one? The logarithm of is 36. We can write it as 6 squared and 216. So that's equal to 6. 216 is 6 times 6 times 6 and square root. So that's equal to 6 to the power of 3 over 2. So now that's equal to 3 over 2 divided by 2. And here we have logarithm of 6 to the base 6. What is 3 over 2 is divided by 2? That's just equal to 3 over 4. Dashel, if you have any questions or if you want to ask something or discuss anything, just let me know. You can raise your hand or you can just stop me and question 3. Find the value of this logarithmic expression again. So here we have log. That is means all the bases are 10, right? So you see here, just let me just write one expression here. I can just write this log. Here we have 32 over 27 plus log 125 over 9 minus, if we have log, and we have 2, right? It just goes here. That will be, what is it? 1 over 45 squared. So that is 1 over 45 squared plus log, and here's 3. Solving this kind of questions now, and all the bases are 10, I can just simplify the thing. Here we have 32 over 27. It is plus, so it is multiplied. 125 over 9. It is minus, that means it is divided here. Here we have 1 over 45 squared. It is plus, that means multiplied. Here we have 3. That's what we have to do here. So now, how can I simplify this without using a calculator? 32, okay. And the times, here we have 125, and times, what is 45 squared? It is 9 times 5 squared. So I can just write it as 5 squared times 9 squared. And also here we have 3. Over, in the denominator, here we have 27 times 9 times, and that's it, 27 times 9. So now if you simplify this, 9 squared, this guys, right, it is gone. And 9 times 3, 27, and also these things are all gone, okay? So that's equal to 32. We can just write it as 2 to the power of 5. And how about 125? It is 5 cubed, 5 squared. So here we have 5 to the power of 5. Or simply, it is 10 to the power of 5. So now third step, if you just put there, so logarithm of all the thing is equal to 10 to the power of 5. So which is equal to 5 times log 10. And since log means it's just the base is 10, logarithm of 10 to the base 10 is equal to 1. So the answer here is, it is 5. So the whole thing is equal to 5. Another example, question 4. Let's use black here. So again, log, right? Log and log and log. All the bases are 10. So immediately from here, what can we do here? So the first step is this 2 comes to the power, right? So here we have 5 over 3 squared. Minus means it is divided here. Here we have 8 over 5 plus it is multiplied. Also, this 2 comes inside as a power 3 squared. So here we have 3 squared. And minus means division, right? So 125 over 8 plus, that means multiplied. Here we have 10. Actually, this 1 in a way you can just write it as this. And now the only thing is just fraction we have to simplify. The first one is 5 squared, that is 25 over 9 times 8 over 5, that is 5 over 8 times, this one is 9 times 8 over 125 times 10. So from here, this 9 and 9, they are gone. 8 and 8, also they are gone. 25 times 5, 125. And also this 125 and 125, it's gone. So it's just equal to 10. So the second step is then, what is it? It's logarithm of the whole thing is equal to 10 to the base 10, which is equal to 1. So that thing is equal to 1. Okay, question 5. Solve the equation for x. So I think you have now idea how to solve this. So this 5, right, I can just take to this side and convert this into exponential form step by step. The first one is logarithm of, what is it? Logarithm of x to the base 3 to the base 4 is equal to 5 to the power of 0, which is equal to 1. In the second step, the logarithm of x to the base 3, that's equal to 4 to the power of 1, that's equal to 4. Dot, 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 then what is x? X equals 3 to the power of 4, that's equal to 81. In question 6, find the numerical value of x plus y plus z if logarithm of x to the base 7 to the base 3 to the base 2 is equal to logarithm of this, and everything is equal to 0. How do you find this? You should just do this one by one. So the first part is solution. Okay. The first one is just if you take this one, right? So that's equal to 0. And also the thing is equal to 0. And also this logarithm is equal to 0. Now from here, right, 2 to the power of 0, that's equal to 1, right? So here we have logarithm of x to the base 7 to the base 3. We have something like this. That's equal to 2 to the power of 0. That is just 1. And after that, what is logarithm of x to the base 7? That's equal to 3 to the power of 1. So then from here, what is x? X is equal to 7 to the power of 3 to the power of 1, which is equal to just 7 cubed. What is 7 cubed? 7 times 7, 49. 7 times 49 is 343. Okay, so now you got the idea now. From here, then what is y? From here, then y is equal to, starting from 2, right? That is 2 to the power of 7 to the power of 3 to the power of 0, which is equal to 2 to the power of 7, 3 to the power of 0, that's equal to 1. So 2 to the power of 7, that's equal to, what is it? 128, right? 5, 6, 7, that's 128. And how about z then? Z will be equal to, starting from the innermost base, that is 3, 3 to the power of, second one is 2, 2 to the power of, third one is 7 to the power of 0, which is equal to 3 to the power of 2, and 7 to the power of 0, that's equal to 1. It's just 2, so that's equal to 9. What is the question? We need to find x plus y plus z. So x plus y plus z, and x is equal to 3, 4, 3, and y is equal to 1, 2, 8, and z is equal to 9. And 343, right? 343 plus 128 plus 9, that's equal to, actually, what is it? 343 plus 9, it is 352. 352 plus 1 to 8, that's equal to 480. So x plus y plus z is equal to 480. Another question, solve the equation for x. So here, x plus 3 and the x minus 3, immediately before we solve this, okay, just where we should look for the answer, the solution, what interval. So x plus 3, it should be greater than 0, and x minus 3, it should be greater than 0. So which means that actually, if you just combine these two things, x is greater than -3, x is greater than 3, so x should be greater than 3. So we need to look for the solution over this interval. So number 2 now, bases are the same, right? We can just write it as logarithm. Here we have x plus 3 times x minus 3 to the base 4. On the right hand side, we have 2. So if I just convert this into exponential form, here we have x plus 3 times x minus 3, that's equal to x squared minus 9, because a plus b, a minus b. On the right hand side, we have 4 squared. What is x squared here? It is 16 plus 9, that's equal to 25. And since x should be greater than 3, so negative answer is rejected. We have only one solution. X should be equal to 5. That's the solution of this equation. Okay, question 8. How many questions we have? Okay, we have 12 questions. Yes. We have how many minutes? 24 minutes. 4 more questions. Good. And solve the equation here. Again, from looking at the values of these functions by x plus 3 and x plus 1. So from here that x should be greater than -1. Because the first one, x should be greater than -3. Second one, x should be greater than 1. So the intersection of these domains gives us that x should be greater than -1. Okay. So, and after that, we can just use the properties of logarithms and simplify this. On the left-hand side, right here, we have 2 goes to the front, the power. So here we have logarithm. Here we have x plus 3 squared. And base is 3. And here we have minus. So here we have divided, right, by what? By x plus 1. So that is the whole thing. On the right-hand side, we can just write it as logarithm 2 cube. Actually, no, should I? Yes, because I'm going to drop the logarithms. Now, if you just look at this logarithm parts, right, they are the same, this logarithm of 3 and also logarithm of 3, we can just drop them and change this into another equivalent exponential equation. What we have here, that here we have, not exponential, actually it will be polynomial equation, x plus 3 squared over x plus 1. On the right hand side, 2 cubed, that's equal to 8. So if you just cross multiply or multiply both sides by x plus 1 and expand this, here we have x squared plus 6x plus 9. On the right hand side, we have 8x plus 8. Or x squared, 6x minus 8x, that's equal to minus 2x. 9 minus 8, that's equal to plus 1, that's equal to 0. And it's just a perfect square, right? You can just write it as x minus 1 squared is equal to 0. Dot, dot, dot. It has only one solution, that x should be equal to 1. And 1 actually belongs to this interval, right? We are looking for the solution here from -1 to here. And 1 is somewhere here, so it is the solution. Another example, a little bit tricky one, but it's fine. So logarithm of x to the base 5 minus logarithm of x squared to the base 5 is equal to 3. So immediately, what are the possible solutions? Where should we look for the solution of this equation? So the second one, we have no problem. X squared, only x should be different from 0. But the first one, right, x should be, what is it, greater than 0. So actually our solution should be from not inclusive, from 0 to infinity. So somewhere here. Okay, so let me label this logarithm of x to the base 5 by w. So there then we'll have here w squared minus this 2, right, just comes to the front. So here we have 2 times w. And take 3 to the left-hand side. Here we have minus 3 is equal to 0. So if you factorize this, I can factor because negative 3 times 1, negative 3 plus 2. So it is w minus 3 and w plus 1 should be equal to 0. So from here, w is equal to 3 or w is equal to negative 1. What is w? W is logarithm of x to the base 5. So logarithm of x to the base 5 is equal to 3, or logarithm of x to the base 5 should be negative 1. Now from here we can write the solution. So x equals 5 cubed, that's equal to 125, or the second one is 5 to the power of minus 1, that's equal to 1 over 5. So it has two solutions. It is either 125 or it is 1 over 5. Both are greater than 0. So both are suitable answers or solutions to this equation. Okay, 10 and 11, 12. Okay, here we have 3 questions left. Solution. So here we have a system of equations involving logarithm. Again, system of equations, we have to change them into exponential forms, and exponential forms impossible into polynomial function, equations, then solve this. Looking at the first equation, on the left-hand side, we have only one logarithm. So I can just write it as x plus 2y minus 3 equals 3 to the power of 1. And how about the second one? The right-hand side, I can just change it as logarithm of 3 to the base 3 plus logarithm of y squared to the base 3, right? Because this 2 will be the power of y. And if we just combine this, what we have here on the left-hand side, we have 2x plus 3. On the right-hand side, if you just combine, because it's plus, it will be multiplied. There we have 3y squared. So these two equations and systems are equivalent. Now, if you simplify the first one, here we have x plus 2y. Take negative 3 to the right-hand side, it will be 6. And how about the second one? The second one is what we have here, 3y squared equals to x plus 3, right? So here we have 3y squared equals to x plus 3. So from the first equation, I can just express x in terms of y and substitute into the second equation and solve this. So from here, x equals 6 minus 2y. Now let's substitute this into this first equation. Then here we have 3y squared, right? Minus 2 times x, that is 2 times x. What is x? 6 minus 2y, using just substitution method. And also 3, take to the right-hand side, it is minus 3 is equal to 0. What is it? Again, we have quadratic equation. So here we have, if you simplify and bring into standard form, 3y squared, negative 2 times negative 2, it is positive 4y. And negative 2 times 6, negative 12, minus 3, it is negative 15. So that's equal to 0. So now we have to solve this quadratic equation. Let's try solving to solve this by factorization. We have prime number. 3 is a prime number. The only way is we can write it as 3y times y. And how about 15? So that cross multiply and the sum should give us 4. It is 5, 3. I think it works. 5 and it's 3, right? So it is 9. It is y. It should be minus. So I will put minus here. So if you cross multiply now, 3y times y, 3y squared, negative 5 times 3, negative 15. If you cross multiply, 3y squared minus 5y is equal to 4y. So we can factorize it as 3y minus 5. And y plus 3 is equal to 0. So from here, y is equal to 5 over 3, or y is equal to negative 3. If y is equal to 5 over 3, what is x? Just write 5 nicely. So this one is 5. If y is equal to 5 over 3, then x will be 6 minus 2 times 5 over 3. It is 5 over 3. That's equal to 8 over 3. So that's equal to 8 over 3. And if y is equal to negative 3, it is 6. It will be 12, right? But negative 2 times negative 3 is 6. 6 plus 6, 12. So we have two possible answers. So are they all possible answers? With x, we have no. Okay, the second one, 2x plus 3, in both cases, it is positive. And with y, because of logarithm of y, right? So it's not possible. So that's why this answer is rejected. So the automatically also this x cannot be equal to 12. So what are the possible answers here then? And dot, x equals 8 over 3. And y is equal to 5 over 3. This is the solution of the given system. It has only one pair of, one solution. The solution contains x and y. So these are the two solutions. So let x and y be positive real numbers not equal to 1. Find logarithm of y to the base x times logarithm of x to the base y. So positive real numbers not equal to 1. Solution is here. So let me just label this expression by capital A. So this capital A will be equal to logarithm of x. I can just write it as logarithm of x to the base y over, using that property, I can just write this logarithm of x to the base y. So it's just equal to 1. Whatever it is, they are not equal to 1, so it's equal to 1. And the last question, logarithm of solve the equation for x log x minus 3 times logarithm of 10 to the base 10 to the base x plus 2 is equal to 0. Okay. One thing we have to know here is actually this logarithm solution log of x to the base 10, right? I can just write it as 1 over log 10 to the base x, right? And suppose that's actually that thing, logarithm of x to the base 10, let's say it is w, right? So at the time, the equation becomes w minus 3 times, what is logarithm of, if it is w, logarithm of 10 to the base x, right? It will be 1 over w. So here we have 1 over w plus 2 is equal to 0. Now from here, if you just, since we know that w is not equal to 0, if w is equal to 0, right, it's not possible. Since we know that w is not equal to 0, I can multiply both sides by w. At the time we have this equation, w squared plus 2w minus 3 is equal to 0. If you factorize this, 3 times negative 1, it is negative 3. 3 plus negative 1 is equal to 2. So I can factorize as w plus 3 and w minus 1 is equal to 0. Now from here, okay, w is equal to negative 3 or w is equal to 1. What is w? W is logarithm of x. Just continue from here. What is w? The first step, let's say. The second step, w is logarithm of x to the base 10. That's equal to the first one is negative 3. From here, x equals 10 to the power of negative 3, which is equal to 0.001, or just 1 over 1,000, or just 1 over 1,000. And the second one is logarithm of x to the base 10 is equal to 1. So from here, what is x? X equals 10. And both are not equal to 0, greater than 0, not equal to 1. So these are possible answers. It cannot be 1. It cannot be, because in the base it should be different from 1. So the answers are x equals 1/1000, or x equals just 10. These are the solutions of this equation. That's the end of this class for this week. If you have any questions related to logarithm, you may ask. Okay. If not, I'm just going to finish this class. Do you have any questions, Dashel?
None, sir. I have no questions.
Okay, Dashel, if everything is good, have a nice weekend. Okay, I will see you next week. Okay,
You too,
bye-bye.
sir. Have a nice
Thank
day.
you.
Goodbye.
Bye-bye.